Welcome back to this quiet corner of the universe where you can rest, unwind, and drift towards sleep while learning something calming and wonderful. As you settle in and get comfortable, this evening's journey takes you far beyond the warm inner planets, out past the giant worlds, and deep into the soft outer dark where a tiny world waits with a surprising amount of beauty and mystery. Tonight, you and Pluto will keep each other company. Before we drift any further, may I ask where in the world you're watching from tonight? I always love seeing how far these peaceful science journeys travel, and if you enjoy these quiet explorations, a gentle like and a subscribe really helps this little channel continue growing across the cosmos. To everyone who has already joined this sleepy community, thank you so much. Please do tap the notification bell as well so you do not miss the next calm adventure. I will do my best to keep this soothing and restful, but every now and then the universe becomes so fascinating that it might hold your attention a little more than planned. If this one keeps you awake for a moment or two, at least you will drift off slightly wiser than when you arrived. As you and Pluto begin this quiet journey together, here is something to wonder about as you settle deeper into the dark. How did such a tiny, distant world end up reshaping the story of our entire solar system? Pluto sits so far away that sunlight takes hours to reach it, and yet this small, frozen world has captured more curiosity and emotion than worlds many times its size. In the soft silence of the outer dark, it moves along its stretched-out path with a calm patience that almost feels timeless. This introduction eases you gently into that distant environment, preparing the mind to slow down and settle into the long rhythm of a place where seasons last decades and shadows stretch for miles. Here you begin to understand why Pluto became such a point of fascination. A world discovered by studying faint specks on old photographic plates. A world whose size was misunderstood for decades. A world that turned out to be far more alive, far more complex, and far more surprising than anyone expected. And a world that, despite being demoted from the list of planets, still holds an emotional place in the hearts of people all over the world. This quiet moment is where the journey takes shape, not through facts alone, but through gentle curiosity, through the feeling of drifting outward, letting the noise of daily life fade behind you, and allowing your thoughts to move slowly enough to notice the details of a frozen world that sits on the threshold between what is known and what is still waiting to be discovered. As you settle further in, one question begins to guide the journey forward. What makes Pluto, of all the distant worlds, so astonishing once you finally see it up close? The journey outward begins gently, almost without you noticing, the way twilight slips into night. You start in the familiar warmth of the inner solar system, a place of bright sunlight and quick orbits, where planets circle the sun in tidy, predictable paths. But as you drift farther from that comfortable center, the light softens. The space between worlds grows wider. The sun becomes a little smaller, a little dimmer, a little less commanding with every million miles you travel. There is no sudden change, only a long, steady quieting, as though someone is slowly turning down the brightness of the universe. The warmth that once wrapped the inner planets fades first. In those close regions, sunlight pours onto the rocky surfaces of Mercury, Venus, Earth, and Mars at strengths and temperatures that can shape landscapes, stir atmospheres, and carve entire climates. But as you drift outward, the grip of sunlight loosens. It falls away in gentle steps, thinning into something pale and cool. By the time you reach the orbit of Jupiter, the sun feels more like a distant lamp than a nearby star, and even this fading light will seem bright compared with what lies ahead. Still you drift outward, past the gas giants with their broad, swirling atmospheres and deep, complex storms. These worlds remain familiar in their own way, massive, colourful, full of motion and activity. They each carry families of moons, miniature systems moving in harmony around them. They feel alive, dynamic, almost crowded, even out in this colder realm. But beyond them the scene changes. Once you pass the orbit of Neptune, the last of the giant worlds, the solar system begins to stretch and open. Everything becomes quieter. Space itself seems to widen into something gentler and more hushed. Here, sunlight becomes the faintest whisper. It still travels outward, still reaches every corner of the solar system, but by the time it arrives this far out, it is weak enough that an afternoon on Pluto receives about the same warmth as Earth would feel from a sunset more than 3,000 times dimmer. The glow that once supported oceans, forests, storms, and seasons becomes a pale silver thread, barely enough to light the ground. If you held out your hand here, you would still see it, but only faintly, as though lit by a winter sky just before night takes over completely. The temperature follows the light. Close to the sun, heat shapes everything. It melts ice, drives winds, freezes and thaws water, and sculpts the surfaces of planets over time. But out here, heat has very little to work with. The cold deepens steadily as the distance grows, until it sinks to levels where gases like nitrogen and methane, which are airy and playful on Earth, settle onto the ground as solid ice. Even shadows behave differently. They do not just darken the landscape, they harden it. A place that spends too long without sunshine becomes colder still, locking the surface into patterns of frost and frozen air. As you move farther from Neptune, the feeling of space changes entirely. The planets near the Sun are relatively close neighbours, separated by distances that seem large only until you compare them with what lies in the outer dark. Out here, the gaps grow so immense they become almost abstract. Between Neptune and Pluto is a gulf so wide that a journey across it would take years at the speed of a modern spacecraft. And Pluto is not even at the true edge. Beyond Pluto stretches a vast region filled with icy debris, ancient leftovers from the early solar system, scattered across distances so great that no single glance could take it all in. This is the beginning of the Kuiper belt, a ring of frozen bodies circling the Sun in a broad, quiet arc. Some are as small as mountains, others are large enough to be worlds of their own. But none of them glow, none shine brightly, and none give off heat. They drift silently through cold, thin sunlight, each one minding its own slow orbit. It is a place where time feels stretched, where nothing seems urgent, and where worlds can take millions of years to change their surfaces even slightly. As you glide through this region, you notice something about the silence. It is not empty, it is peaceful. The planets of the inner solar system feel busy, full of storms, collisions, eruptions, and weather. But the outer regions hold themselves with a different kind of presence. They feel steady, serene, and ancient, as though they are keeping secrets from the earliest days of the solar system. Here, distance becomes a kind of cushion. Light travels for hours to reach these worlds, and everything that happens does so at a slower rhythm. Even the orbits stretch into vast, gentle loops that take centuries to complete. This slow shift from the familiar to the unknown is where the journey truly takes shape. you begin to realize how small the warm inner worlds are compared with the enormous space that surrounds them. The majority of the solar system is not bright or warm or crowded. It is this, a wide, quiet expanse where sunlight arrives in thin, silvery beams, and the cold settles softly into everything it touches. The planets you know feel like islands compared with this great dark ocean. And yet, it is in this stillness that Pluto lives. A tiny world drifting through a space so large it almost seems endless, illuminated by a sun that is no longer a fire but a distant star. If you were standing on its surface, the sun would look like a bright dot you could cover with the tip of your finger. But even at this distance, even at this cold, Pluto is not a frozen relic or a dead rock. It is part of a complex, graceful region filled with ancient objects and untold stories. All of this builds toward the gentle realization that Pluto is not an outcast at all. It is a citizen of the outer solar system, living in a landscape shaped less by heat and more by time. Its neighborhood is vast and quiet, but it is not empty. It is a region of frozen plains, drifting worlds, and the faintest touch of sunlight, stretched across unimaginable distances. A place that asks you to slow down, breathe softly, and take in the scale of everything around you. And as the cold grows deeper and the light grows dimmer, one question begins to form in the silence. What kind of world could take shape in a place this far from the warmth of the sun? The idea that something waited beyond Neptune began long before Pluto ever appeared on a photographic plate. It started with a feeling, a suspicion carried quietly through observatories in the late 1800s and early 1900s. Astronomers studying the orbits of Uranus and Neptune noticed small irregularities, tiny deviations that did not quite match the predictions made by Newton's laws. These were not dramatic shifts, nothing that would catch the eye of a casual observer, but to a patient astronomer they stood out like faint ripples on a still pond. Something, they believed, was tugging at the outer planets. Something faint, distant, and heavy enough to leave fingerprints in their orbits. At the time, this was not an unusual line of reasoning. After all, Neptune itself had been discovered because of the way its gravity pulled on Uranus. Astronomers had looked at the irregular motions of Uranus, performed careful calculations, and correctly predicted that another planet must be hiding in the darkness. When they pointed their telescopes toward the exact region the equation suggested, Neptune appeared. It was a triumph of mathematics and patience, and the memory of that discovery lingered in the minds of astronomers for decades. If it worked once, perhaps it could work again. One of the people most captivated by this idea was Percival Lowell, a man with an intense curiosity about the solar system and a great willingness to chase mysteries that others found too faint or too strange. Lowell had already become famous for his controversial ideas about canals on Mars, but his attention gradually shifted toward the far edges of the solar system. He was convinced that another world existed beyond Neptune, a world whose gravitational pull was responsible for the small but persistent quirks in the orbits of the giant planets. Lowell gave this hypothetical world a name that would echo for decades: Planet X. The letter was not chosen for dramatic effect, though it certainly gave the idea a sense of intrigue. In astronomy, the letter X simply stood for unknown, but the imagery stuck. Planet X sounded mysterious, important, something almost myth-like. It could have been large or small, bright or dim, but the truth was that no one knew. Lowell saw it not as a fantasy, but as a problem waiting to be solved. He approached the idea with careful calculation. Using the observed motions of Uranus and Neptune, he attempted to determine where this unknown planet might be hiding. His math led him to a rough patch of sky, a region where he believed a new world might pass. But finding it would not be easy. Even with the best telescopes available at the time, faint distant objects looked like tiny dots of light barely different from stars. To find a moving world among them, you had to compare photographs taken days or weeks apart and search for a single dot that had shifted slightly. It was slow, delicate work, the kind that required a steady mind and extraordinary patience. Lowell began a long campaign of sky surveys, capturing photographic plates of the night sky and searching them for any sign of movement. Plate after plate was developed, examined, catalogued, and filed. He wrote extensively about his predictions, refining them as new data came in. His observatory and flagstaff, perched high in the thin air of Arizona, became the quiet center of the search. Yet despite his dedication, Planet X refused to reveal itself. Night after night, Lowell's team scanned through the glittering fields of stars, looking for a faint drifting point of light. The search stretched over years, yielding nothing conclusive. The sky simply held too many dots, and each photographic plate captured thousands of stars, any of which could easily be mistaken for a planet if the comparison between plates was even slightly off. It was like trying to find a tiny speck of dust on a tiled floor, where every tile looked almost identical, and the speck might not even be there at all. Still, Lowell remained confident. He believed that his calculations were correct, that the oddities in Neptune's orbit meant something real was out there. His notes grew increasingly detailed, his predictions more refined. But even as he narrowed his search, his health declined. He continued working, convinced he was on the edge of a discovery that would reshape the solar system. When he passed away in 1916, Planet X remained hidden, and the search fell silent for a time. Even so, Lowell's work did not disappear. His calculations, his predictions, his sky photographs, all of them remained preserved at the observatory. Other astronomers, curious about the mystery he left behind, continued to discuss the possibility of a ninth planet. Some doubted it. Others found the idea too tempting to dismiss. The notion of a hidden world tugged at the imagination, and the slight irregularities in planetary orbits kept the discussion alive. Over the next decade, the search resumed in quiet intervals. Astronomers re-examined plates, rechecked Lowell's math, and gathered new observations. Yet, for all the effort, Planet X still refused to show itself. Some began to suspect that the irregularities Lowell had relied on were not caused by a hidden planet at all, but by slight errors in measurements or limitations in the data. The outer solar system was simply too far away, too dim, and too poorly understood for anyone to be completely certain. Then came a new generation of sky surveys, using sharper equipment and more careful procedures. Among those involved was a young assistant at Lowell Observatory named Clyde Tombaugh. He was given the task of systematically photographing sections of the sky and comparing the images for any sign of movement. It was exactly the kind of patient, meticulous work that Lowell had pioneered, but now performed with slightly improved tools and a set of more refined expectations. Each pair of plates revealed countless stars frozen in place, but Tombaugh continued with absolute discipline. He scanned every square millimeter with an unwavering focus, looking for the faintest shift. And months into his search, he noticed something small, just a tiny speck of light, moving against the backdrop of fixed stars. It was subtle, almost easy to overlook, but there it was, a slow, steady drift. What Tombor found was Pluto. The world Lowell had spent years hoping to discover had finally revealed itself to another set of eyes. It was smaller and fainter than Lowell expected, far less massive than his calculations had predicted, but it was real. After decades of searching, the idea of Planet X had finally led to an actual world. But it is important to realize that Pluto was not discovered by accident. It was found because of years of groundwork laid by astronomers who believed the outer solar system held secrets worth uncovering. Even though Lowell's calculations were not perfect, his determination and dedication pointed others toward the possibility of something waiting beyond Neptune. And so the long road to Pluto began with a question, a suspicion, and a man who refused to let faint irregularities go unexplained. That quiet persistence eventually brought a tiny distant world into view, one that would go on to challenge expectations, reshape definitions, and spark some of the most passionate debates in modern astronomy. But before any of that could happen, one puzzle had to be answered. What exactly had astronomers found out there in the cold dark, drifting so quietly at the edge of everything? Clyde Tombaug's path to discovering Pluto did not begin with an advanced university education or a powerful research grant. It began on a farm in Kansas, where the night sky stretched wide and clear above the fields. As a teenager, he built his own telescopes by hand, grinding and polishing the mirrors himself with the kind of patience that would later define his scientific career. He studied the sky with quiet dedication, sketching detailed drawings of Jupiter and Mars, not because anyone required it, but because he felt compelled to capture what he saw with the greatest accuracy he could manage. Those sketches, made with steady hands and a careful eye, eventually found their way to Lowell Observatory in Arizona. The observatory staff, impressed by the precision and commitment behind the drawings, invited him to join as an assistant. It was a remarkable moment, a young man with no formal degree, stepping into the world of professional astronomy through sheer perseverance. When Tombaugh arrived at Lowell Observatory in 1929, he was given a task that was as monumental as it was repetitive. He was to continue the search for the mysterious Planet X, the world Percival Lowell believed was lurking beyond Neptune. The observatory had the equipment, the sky charts, and years of calculations pointing to possible locations of the hidden world. What they needed was someone with both the endurance and the sharp attention to detail required for the final, most difficult step. They needed someone who could look at thousands of tiny points of light and spot the one that did not belong. The tool Tombaugh relied on was called a blink comparator, a device that allowed him to compare two photographic plates of the same patch of sky taken at different times. When the images were placed side by side in the comparator, a mechanism let him blink rapidly between them. Stars remained fixed in place, perfectly aligned in both images. But any object that had moved during the interval between exposures would appear to jump slightly from one image to the other. It was a simple concept, but the execution required immense patience. Each photographic plate captured tens of thousands of stars. Each pair of plates had to be examined slowly, square by square, with complete focus. This was the work Tombaugh did day after day and hour after hour. He would lean over the blink comparator, adjusting the focus, blinking through sections of the sky again and again, scanning for the faintest hint of movement. The task could have easily overwhelmed someone with less determination. The plates were large, the fields crowded, and the possibility of finding a distant icy world was not guaranteed. But Tombaugh was steady. He worked with quiet persistence, moving methodically through every image, trusting that careful observation would eventually reveal something hidden. Then, on a cold evening in February of 1930, as he blinked through yet another pair of plates taken weeks apart, he noticed a tiny speck of light shift slightly. It was not dramatic. It was not even easy to see at first, but it moved. A star stays still. A planet drifts. Tombaugh marked the dot, checked it again, and confirmed the motion. What he saw was not a star, not an artifact, not a smudge or flaw in the plate. It was an object moving steadily against the background of fixed stars. He had found something. Tombaugh did not rush to announce his discovery. Instead, he prepared a series of careful checks, confirming that the moving speck behaved consistently over multiple observations. He traced its motion across the plates, watched it inch along its distant orbit, and documented everything meticulously. Only when he was absolutely certain did he bring the results to the observatory's director. The reaction inside Lowell Observatory was a mix of excitement and disbelief. After decades of searching, calculations, and speculation, a new world had finally appeared. The observatory kept the discovery secret for several weeks, while additional observations were made to confirm its orbit. This was not simply a small asteroid or a passing fragment of rock. It was something more substantial. It was far away, well beyond Neptune, and moving with the slow grace expected of a distant planetary body. When the news was finally announced to the public on March 13, 1930, it made headlines around the world. Newspapers ran stories celebrating the first new planet discovered in the solar system since Neptune in 1846. People were thrilled by the idea of a hidden world brought into view by a young astronomer with homemade telescopes in his past and a blink comparator at his side. The question of what to name this new world drew enormous interest. Suggestions poured in from across the globe. In England, an 11-year-old girl named Venetia Burney proposed the name Pluto. She chose it not only because the god of the underworld lived in a distant, shadowed realm, but also because the first two letters matched the initials of Percival Lowell, whose efforts had laid the foundation for the search. The name caught the attention of astronomers at Lowell Observatory, and within weeks it was officially adopted. Pluto fit perfectly, mythological, evocative, and subtly tied to the man who had dreamed it into the scientific conversation decades earlier. As soon as Pluto was named, it was welcomed into the family of planets without hesitation. In the 1930s, the solar system was understood very differently. Pluto was believed to be roughly the size of Earth's moon, or perhaps larger. Many astronomers assumed it might even rival Mars in mass. Only later, as measurement techniques improved, did the scientific community realize just how small Pluto truly was. But in those early days, size mattered less than discovery. The public embraced Pluto immediately, charmed by its mysterious nature and enchanted by its symbolic place on the far edge of everything familiar. Clyde Tombaugh became a celebrated figure within astronomy. His discovery was hailed as a triumph of patient observation and human dedication, and rightly so. He had done something extraordinary, not by accident, not through luck, but through countless hours of disciplined, careful work. His story stood as a reminder that science often advances not in leaps and bursts, but in the quiet, steady progress of people willing to look closely at what others might overlook. Pluto earned its place in the solar system not because it fit neatly into a definition or matched someone's expectations, but because it was real. It moved. It existed where someone had once only guessed, and it took the skill and determination of a young astronomer to bring it out of the darkness. Pluto's discovery remains one of the most human moments in modern astronomy, born not from advanced technology, but from persistence, curiosity, and the willingness to stare at thousands of silent stars until a single one finally moved. Pluto entered the solar system's story wearing a much larger coat than it deserved. When Clyde Tombaugh first revealed the faint moving dot on his photographic plates, astronomers naturally assumed it must be big. In those early months of 1930, there was very little information to work with. Pluto was too distant to appear as anything more than a speck of light, and that speck did not give away its size. So astronomers fell back on the assumptions built from the earlier search for Planet X, the hypothetical world Percival Lowell believed was causing subtle disturbances in the orbits of Uranus and Neptune. If that unseen world was massive enough to tug on giant planets, surely the object Tombaugh had found must be large. Many imagine Pluto as something close to Earth in scale, perhaps even larger than Mars. Newspapers printed diagrams of the solar system showing a ninth planet nearly as big as Earth, drifting majestically beyond Neptune. The idea captured the public imagination. People liked the thought of a substantial new world waiting out in the cold, something grand and important added to the cosmic family. It gave a sense of symmetry to the solar system. 4 rocky planets, 4 gas giants, and one more planet occupying the distant frontier. Pluto seemed to balance the arrangement, giving the solar system a neat sense of completion. But the truth was that astronomers had almost no evidence to support these early guesses. They were basing Pluto's supposed size on expectation rather than measurement. As telescopes improved through the 1930s, astronomers tried to estimate Pluto's size using brightness. But this method was tricky, because brightness does not only depend on size, it also depends on reflectivity. A small object coated in bright reflective ice can appear just as luminous as a much larger, darker object. Without knowing Pluto's surface composition, early calculations drifted wildly. Some astronomers estimated that Pluto was roughly the size of Earth's moon. Others believed it might be even bigger. Each new measurement seemed to shrink Pluto further, but no one could agree by how much. By the 1950s, evidence was mounting that Pluto was not the enormous Planet X people once imagined. Observations of Neptune's orbit improved, and astronomers realized that many of the irregularities Lowell had noticed were caused by errors in the data, not by the presence of another massive world. The need for a large, unseen planet diminished. Pluto no longer required the mass that Lowell had attributed to it, but the scientific community still lacked the tools to measure its true size directly. Pluto remained a faint spot, stubbornly refusing to reveal more than the slightest details. What puzzled astronomers most was Pluto's faintness. If it truly were a world much larger than Earth's moon, it should have reflected enough sunlight to appear brighter in their telescopes. Instead, Pluto was barely visible at all, glowing as a soft pinpoint that often seemed on the verge of disappearing. Some astronomers wondered if its surface was unusually dark, coated in materials that absorbed most of the light. Others considered the possibility that Pluto's orbit carried it into dusty regions that obscured its true brightness. The explanations grew increasingly creative because Pluto refused to align with any of the expected patterns. Then something significant happened in 1978. While studying Pluto through a telescope at the United States Naval Observatory, astronomer James Christie noticed an odd bump on one of the images. It appeared, disappeared, and reappeared over several days. After checking carefully, he realized the bump was a moon, Pluto's first known companion, later named Charon. The discovery of Charon changed everything. By studying the orbital dance between Pluto and its moon, astronomers could finally calculate Pluto's mass with accuracy. The result was astonishing. Pluto's mass was only a tiny fraction of what many had believed. It was nowhere near Earth-sized. It was not even Mars-sized. It was barely 1/5 the mass of Earth's moon. This revelation rippled through astronomy. The ninth planet, once imagined as a distant giant, had been revealed as a small icy world, lighter and far less imposing than expected. Its faintness suddenly made sense. It was not a large world with a dark surface. It was a small body reflecting limited sunlight across an immense distance. Even so, its reflectivity turned out to be higher than many imagined. Pluto was covered in bright ices, nitrogen, methane, and traces of carbon monoxide that helped it shine more strongly than such a tiny world otherwise would. Without those ices, it might have been nearly invisible. As Pluto's true nature came into focus, astronomers began to reevaluate past assumptions. The early belief that Pluto was Earth-sized had been built on the hope of a massive planet X. When that idea weakened, the estimates shrank, and once Charon revealed Pluto's mass, the shrinking stopped abruptly. The solar system's ninth planet was not a giant. It was a miniature, a cold, icy object with less mass than expected, a thin atmosphere and a faint glow that belied its brightness up close. Pluto had gone from imagined giant to confirmed lightweight, and it had done so over decades of careful observation. This evolution of Pluto's identity did not diminish public affection for the world. If anything, it made Pluto more intriguing. People found something endearing about a tiny planet hiding at the edge of the solar system, discovered through perseverance rather than dramatic brightness. It felt like the underdog of the solar system, punching above its weight simply by existing in a place few had expected to find it. The more astronomers learned, the more Pluto's story took shape, not as a disappointment, but as a quiet revelation. What astronomers misunderstood at first was not the data itself, but the assumptions behind the data. They expected a large world because the theory of Planet X required one. They expected a certain brightness because they assumed Pluto's size matched those predictions. When reality refused to cooperate, the theories held on longer than they should have. And yet this confusion was also necessary. It drove the observations, it fueled the decades-long search, and eventually it led to one of the most interesting discoveries in modern planetary science. By the time new technologies and space missions allowed astronomers to glimpse Pluto in greater detail, the scientific community had embraced its true nature. Pluto was small, faint, cold, and distant, but it was also unique. Its surface was covered in heart-shaped plains, icy mountains, and drifting hazes that no one had expected. Far from being a dull, frozen remnant, Pluto turned out to be complex and surprisingly active, a world with its own character, its own history, and its own secrets. Pluto's identity shifted long before anyone debated its planetary status. It went from imagined giant to misunderstood anomaly, then from anomaly to cherished world. Each stage revealed something new, peeling away old assumptions and replacing them with deeper understanding. And the further astronomers looked, the more they realized that Pluto did not need to match expectations to be extraordinary. Its mystery was never about size. It was about the quiet defiance of a world that refused to fit neatly into the categories humanity had built. All of this raises a gentle question that would guide Pluto's story for decades to come. How could such a tiny, faint world turn out to be one of the most surprising places in the entire solar system? The Kuiper belt is a place where the solar system keeps its oldest memories. It is a region so distant and so cold that almost nothing changes quickly. Time here moves in slow, soft steps, preserving ancient materials from the very beginning of the sun's formation. When you drift into this part of the solar system, you are stepping into a kind of cosmic attic, filled with icy fragments that never grew into full planets, but never disappeared either. These frozen pieces have been circling the sun for billions of years, untouched by warmth, protected from disruption, and carrying clues to the earliest chapters of our cosmic history. To understand why the Kuiper belt exists at all, you have to picture the solar system as it was in its infancy. In those early days, everything was chaotic. Dust, rock, gas, and ice swirled around the newborn sun, colliding, clumping, and sometimes merging into larger bodies. Near the sun, the intense heat drove away lighter materials, leaving behind heavy rocky debris that eventually formed the inner planets. Farther out, where sunlight lost much of its strength, icy materials could survive. This colder zone produced the giant planets, with their thick atmospheres and massive gravitational pull. But even farther beyond them, past the orbit of Neptune, the sun's warmth weakened so much that only the coldest, most fragile materials remained. Out here, the early building blocks of planets never fully combined into a single large world. Instead, they lingered as countless small icy bodies, each one drifting through the outer darkness. These objects, some tiny, some hundreds of kilometers across, make up the Kuiper belt. They are remnants of a time when the solar system was young, leftovers that never found a place in the grand architecture of planets and moons. Instead, they settled into slow, circular orbits around the sun, forming a wide, gentle ring of icy debris stretching from just beyond Neptune to several billion kilometers outward. For a long time, astronomers did not know this region existed. The objects were simply too faint and too distant to detect with older telescopes. Pluto was the first clue, a hint that another population of icy bodies might be hiding just beyond Neptune's orbit. It took decades before the pattern became clear. Starting in the 1990s, improved telescopes revealed object after object, confirming that Pluto was not alone at all. It was part of a vast community of distant, frozen worlds. Some were small, others surprisingly large, and all drifted through the same quiet neighborhood. This discovery reshaped our understanding of the solar system. The Kuiper belt was not a sparse, empty region with one lonely planet at its edge. It was a teeming, ancient zone filled with icy worlds, each carrying its own story. Some of these worlds orbited neatly, others followed elongated, tilted paths. Some spun rapidly, others rotated unpredictably. The diversity of shapes, sizes, and compositions suggested that the outer solar system had a far more complicated history than anyone had imagined. Within this frozen population, Pluto holds a special place. In some ways, it is entirely ordinary. It is made of rock and ice. Like many other Kuiper belt bodies, it follows a long, stretched-out orbit that sometimes brings it closer to the Sun than Neptune, but most of the time leaves it drifting in frigid darkness. It has a mixture of bright and dark regions on its surface, again common among these distant worlds. If Pluto were discovered for the first time today, it might simply join the growing list of Kuiper belt objects, one more icy world among hundreds. Yet Pluto is also unusual. It is one of the largest bodies in the Kuiper belt, rivaled only by a few other distant objects. It has a complex surface shaped by active processes, something rare in such cold and ancient regions. It has a thin, delicate atmosphere that expands and collapses over its orbit, a behavior few other bodies are known to share. And it has an unusually large moon, Charon, so large that the two bodies orbit a shared center of gravity outside Pluto itself. This makes the Pluto-Charon system behave more like a pair of partners than a planet and a moon, something unique among known Kuiper belt objects. These characteristics set Pluto apart, transforming it from a simple icy body into a world with complex geology, chemistry, and seasonal changes. It is an example of how variety can emerge even in the coldest regions of the solar system. Many Kuiper belt objects are little more than frozen relics, shaped mostly by collisions. Pluto, however, shows signs of internal heat, active ices, and changing landscapes. It is a reminder that distance from the Sun does not necessarily mean inactivity. Even out here, in the quiet cold, worlds can evolve. Comparing the Kuiper belt to the asteroid belt helps make its nature clearer. The asteroid belt, located between Mars and Jupiter, is dominated by rocky fragments. These objects formed in a warmer part of the solar system and tend to be small, irregular, and heavily cratered. Collisions are relatively common there, stirred by Jupiter's gravitational influence. The Kuiper belt, by contrast, is colder, quieter, and far less crowded. Its objects are icy rather than rocky, and many have remained unchanged since the early solar system. Collisions do happen, but they are less frequent and usually slower, allowing surfaces to remain intact for billions of years. This means the Kuiper belt preserves ancient materials with remarkable clarity. Objects here are snapshots of the early solar system, frozen in time and kept safe from the heating, melting, and reshaping processes that affected bodies closer to the Sun. Studying them is like opening a sealed time capsule. Every crater, ridge, and patch of ice tells part of a story that stretches back to the solar system's childhood. Pluto's location makes it a natural ambassador for this region. It is bright enough and large enough to be observed in detail, yet it remains deeply connected to the icy population around it. When the New Horizons spacecraft flew past Pluto in 2015, it did not just reveal the nature of a single world, it provided insight into the entire Kuiper belt. The mountains of water ice, the flowing nitrogen plains, the delicate atmospheric haze, and the unusual variety of surface colors were clues pointing to the processes shaping far more distant bodies. The quiet environment Pluto inhabits shapes everything about it. Temperatures remain low enough for exotic ices to stay solid. Sunlight is too weak to drive rapid change, so landscapes evolve slowly. The vacuum is too thin to scatter sound, leaving the region almost entirely silent. Even time behaves differently here. A single orbit around the Sun takes Pluto almost 248 Earth years, meaning a season lasts longer than a human lifetime. The pace of existence is slow, steady, and serene. In this ancient environment, Pluto is both a representative and an outlier. It shares the Kuiper belt's icy origins and distant orbit, yet it defies expectations by being more dynamic and complex than other bodies nearby. Its heart-shaped plain, rising mountains, drifting glaciers, and shifting atmosphere reveal a world that remains active despite the extreme conditions. This dual identity, ordinary in some ways, extraordinary in others, makes Pluto one of the most intriguing members of its vast frozen community. It is a world shaped by the Kuiper belt, yet capable of surprising even the scientists who study the region most closely. And as the quiet debris of the early solar system continues its slow journey around the Sun, one question begins to form about Pluto's place in this ancient environment. How did such a small, icy world manage to develop such an astonishingly detailed and dynamic surface in a region that has barely changed for billions of years? Pluto's surface looks at first like a quiet patchwork quilt stitched together from light and shadow.